Thank you very much. Thank you for attending this session. So as I was presented, I'm Vladimir, boring Armenian with Russian name. And I'm a full-stack software engineer. That means that I can break stuff on both front-end, back-end, in database. I'm the main responsible person for our security incidents and bugs in our company. Recently, I got interested in DevOps, Kubernetes, so I can now break stuff in distributed manner. Before starting, a few disclaimers. The first one is disclaimer for disclaimers. This is the first disclaimer I have ever written. So maybe there are no disclaimers, just a hint. So let's start. No AI was used during preparation of these slides. This is 100% organic presentation, handcrafted with typos, wrong images, and awful content in it. So no AI, ML, LLM, GPT, or other scary words were used or any harm done to the environment. Questionable content. So normally you assume that attending such presentations you are going to learn something or learn anti-patterns. This is not the case, okay? There are a lot of questions in this presentation that aren't going to be answered. A lot of wrong things are going to be presented to you, and it's up to you to decide whether you are going to use it or not. Please consult anyone before using approaches in this presentation, okay? Anyone who has ever written or sewn a code. And of course, a clickbait title, okay? There is nothing illegal in this presentation. If you think about the state law, of course, if you don't hack some governmental organization and execute my queries there, which are totally harmless, but you may be caught because you have hacked into the government. So these were disclaimers. If you are still here, maybe we can start with our code. So everyone knows that Toki is cheap. That I'll show you the code, and no code here because I want you to present this setup. What we are going to see here, okay? Here we have PostgreSQL, our target database. It's the best database engine according to the bestdatabaseengines.com, okay? It's one of the most used open source database engines. And today we are going to run our Python code inside the database. So pay attention, I'm not going to connect Python to the database. No, I'm going to embed my Python code inside the database. I'm going to run it using this small extension which is called PL-Python-U. U stands for undisputed, so ultimate or uber cool. Unfortunately, it's untrusted. Okay, U is for untrusted, and we are going to connect to Python runtime, which will allow us to use Python standard library and other side packages inside it. Okay. So this is the setup, the base technical part, and let's, for warm-up, look to some simple code here. Okay, I have some Python code inside weird statement do dollars, and everyone loves dollars. Yes, do dollars and dollars language PL Python 3. I'm executing some code and printing platform information. The PL-Py is an interoperability layer of Python, your Python runtime, and your PostgreSQL. So we cannot just print out anything we want. We are showing the PL-Py info here. Simple as this. You can just focus on Python part of this presentation because we are on Python conference. And the SQL wrapper part, if you have any questions later, I will answer them, of course. But just pay attention to the Python. And another code block that I want to show you is a real function, a real database function, which produces a simple string on the output, okay? If, for example, you want to generate some secrets, okay, random tokens, slugs, you can use Python secret data module and use token URL safe. You can define an SQL function, and upon calling, this is the select generate token URL safe, you will get a random URL safe token. You can use this function as a trigger or as a default value, whatever you want. So this tiny code is the most beautiful part of this presentation. You can actually run your code inside the database. So we are not connecting with a client or something else. We are running Python code directly into the Postgres. And this will break the world. I promise you, I'm going to break the world with you here. Another warm-up example here is just like the previous one, but we are computing SHA-3 512. These are totally random numbers here, okay? Whoever doesn't know, it's the hashing algorithm, SHA-3. And we're hashing our super secret password here. So you can set up database to hash your values before inserting or after inserting or in the middle of inserting or I don't know, wherever you want it. The trick here is that PostgreSQL doesn't have SHA-3 hashing by default. If you, for some reason, want to use SHA-3, you need to install an extension. It's called PG Crypto, which is a beautiful piece of software, but it's an extension. It's an addition to your database. So you have to maintain that addition to your database. Or you can use PL Python, which is provided by default and maintained by Postgres development group, and use your hashing algorithm here. Okay, Python standard library provides this hashing algorithm. If you want other algorithms, Blake 3 or whatever you want, you can use them as well. So these were very simple examples. One line of Python code, except the import. You're calling the function. You're calculating something. You're returning the value, for example, the string. So from this part, we can see that PostgreSQL with PL Python maps the data types between Python and PostgreSQL. Okay, so you can generate whatever you want in your Python code and return it to your PostgreSQL environment if there is a mapping between those data types. So I want you to just think about this code, how beautiful it is, or maybe how ugly it is, because it's going to become worse and worse. So the cryptographic hashing is a cryptographic operation. So we're going to jump to cryptography. And the first thing when you want to do a cryptography is that everyone tells you, don't roll your own crypto. So naturally, we're going to roll on our own crypto. Okay? I promise you, everything is secure. Best practices are used. You can always refer to these slides, but please, if anything breaks or leaks, don't refer to me. If everything works, fine, it was me. It was my advice to you. If anything breaks, I'm not involved. Okay, let's start with encryption. First, let's view the SQL part, how we're going to define those functions without Python. Okay, there's a fernet encrypt here, which receives plain text, a file, which stores the private key, which is super secure to store those private keys files. The other way to secure store it, to just plain text show to everyone, this is your private key. Okay, and here will be the body of our function, which uses Python's cryptography library, third-party library, and we're using the fernet here. We are just random checking here if the plain text is null or not, and we're encrypting our plain text. So fernet naturally stands for AES encryption, okay? Because fernet in some universe is translated to AES. I don't know why, what was the choice, but of course you can use this. This is the first example when we are using the, not a standard library package, but an installed package. So this opens a whole new perspective. You can use anything you can install on your runtime in your SQL. You can use pandas, which loads the data frame from a file or CSV file, then it transforms to polars, which does some requests, and then I don't know why. I can go on, but I think that's enough for this example. We get the encryption part. We get this we read key from the file, we encrypt our plain text, we decode it to have a textual representation, and we return it to our function, which expected text here. Now we can store unencrypted data in our database. This can be a before insert trigger. Okay, when you insert your data, the database encrypts your data and stores it encrypted. You cannot do anything with encrypted data. You cannot compare, you cannot query with likeness or something else, but you can store it. So here we have solved the cryptography in the database. Okay, this is the solution. Who believes that this is the solution to the cryptography? No one. Good. Okay, we can proceed. But there is such topic as encryption at rest when your data is encrypted on disk level. So the encryption in database is very important topic. No one wants their data to be leaked or be visible to non-authorized parties. So of course this doesn't solve that issue, but it's a step toward it. We have encryption and we require decryption. Okay, the code is very similar. The setup is very similar. Where we have here Fernet decrypt here, which receives ciphertext. It does the decryption and returns the encrypted part. Okay, and we can see the code here. The same cryptography library is used here. The ciphertext is checked for not being none or null in our database. We read everything. We read the key from our file. We decrypt it and return it. This schema is very usable, but please don't set the key as a default value for your function, because if anyone inspects your database, will see the key, and you cannot rotate the key without changing your function definition. It will be always visible in your write-ahead logs, whatsoever. So please consider storing your keys secretly, maybe using some cryptographic device, PKCS11 device or something else, but storing in some sort of secure enclave here will do as well. Okay? Don't put anything inside your query. Don't provide the secret key to your query. Please encrypt my secret with this key. No, don't do that. Okay? This can be substituted with asymmetric cryptography. Maybe you are storing the public keys and then encrypt, which are public because they are called public keys. Then you can encrypt the secret with those public keys, and only person holding private key corresponding to that public key can decrypt that data. Okay? This is totally working schema, but please be careful. Contact a security expert, psychologist, whoever you want. Okay, but please be very careful not to leak anything. So going forward here, and this is the usage. Okay, we're calling for an encrypt on a string. It returns our ciphertext. We can decrypt it, and we should print the PyCon PyData, hopefully, okay, if it works. So a hardcore analysis ahead. This presentation, some sort of this presentation was presented during Postgres Armenia meetup, and there was a very good question about whether we can write a window function using PL Python. The window function is sort of aggregation on your data without aggregation on your data. You can just aggregate something without grouping by in your database, so it's not important. And I answered no to that question. You cannot aggregate, you cannot write window function in PL Python. But I thought a lot about that question. I did my homework, I studied the documentation, I asked the community, and finally I got the answer. And the answer is no. You cannot write a window function in PL Python. Maybe yet, because there will be some time where those APIs will be exposed to PL Python, because you can write window functions in C language, but not PL Python. But I'm going to use my PL Python function inside the window function, and we'll see how. We're going to create aggregates, window functions depend on those aggregates very much. This is what we are going to have at the end of this part. I want to create a permutation function which computes permutation over these values. This is a table, this is a temporary table with only A, B, C values in it. And it must compute the aggregates, the permutations. This is it will use iter tools module from Python standard library, and we're going to have these values on the output. But having such permutations computed is not very interesting, and we can put these permutations inside a window function. We can compute these permutations over when you don't provide over what? Over everything, over each row in this table, or you can maybe write over partition by some value, and we'll compute the permutations upon those partitions. And as you can see, I have the same permutations as previous one. I just truncated because it's too large here. And you have the same permutations over those values, over those rows. So you can create your own aggregates, provide to a window function, and do a lot of scary analytical stuff, which I don't get. Okay? So that's why I've truncated everything here. What is an aggregate? Aggregate is this boring SQL stuff, which is not important. If you want, there is a step function, return type, finalization function, whatsoever. The important part is that permutation sfunc and permutation final are Python functions. Those are not SQL functions. Oh, they are SQL functions wrapping the PL Python code, of course, but those are implemented in Python. So this straight transition function, okay, the sfunc, which we provided to aggregate, this state function just accumulates the state, because during permutation computation, we don't have to do anything on previous state. Just combines everything together, reduces the values. Okay, it takes if state is none, it is the first state. It is a list, or else it is current state. If value is not none, it appends and returns the current state. And the greatest part of this function definition, which I love and admire very much, I mutate the state and mark this function immutable. Okay, I have achieved. I have broken the immutability. I have achieved the ultimate goal. I have mutated the immutability. Of course, this function is marked immutable because for provided values, it doesn't mutate. If you provide a certain value, it will return the certain outcome for it. But in the scope of the whole aggregate, of course, it changes the state of the whole aggregate, not the return value based on its input. So this is the state transition function, which just aggregates the state. And this is the finalization. When we have the whole state, we can compute the permutation on the whole state, because that's how permutation works. Or no, I don't know. I'm not as good as you on this. I'm using iter tools here. I'm calling the permutations on the state, on the whole aggregated state. I'm dumping it as JSON document because it's nested array, and I'm too lazy to use nested PostgreSQL arrays. Okay, JSON, we can use nested arrays, and I'm just returning it as JSONB data type. So these are not strings, these are objects. So when you query this from your favorite programming language, it will become an equivalent of JSON decrypted document, maybe a dict, or maybe a hash table, maybe some universal data structure, which we are all craving for. And yes, this is all for our aggregation, but of course, there are tons of usable things that we can do with third-party libraries, like polars or something. You can load the windows, the state, into some very complex, very complicated library, do some magic there, and just spit out anything you want from there. Nice. This was the finalization function, and we were going to sentiment analysis. As no one has left yet, I assume that something is fine here. And we're going to analyze some sentiment here without an AI. Just pure statistics, okay? Because AI is based on statistics, maybe, but no one tells us out loud. So what we're going to do here, this is the setup, okay? I'm going to store some user-provided reviews inside my database. It's a simple table. It stores email, it stores the review, and it will compute the reaction, whether it was a positive, negative, or neutral review. With some created timestamp without time zone because it was a muscle memory. I always create something like this, but without time zone. It's always bad to use without time zone. Don't use this. Okay, this is another worst practice from this presentation. And I'm going to create a trigger here to analyze that review before insertion. So when user review comes, we are going to store it into our database. But before storing, we're going to analyze the review, the sentiment of that review before inserting into our database. Okay, before storing it in its final form. And what we're going to do, I'm going to do the text blob library. It's very simple. It uses big dictionary to analyze the sentiment of an English sentence. I'm using it for its simplicity. I don't want to present you multi-layer perceptron, which is going to analyze the universal structure of the sentence and then present to you the weights of that model, which you're going to interpret as, yeah. Okay. So this is a text blob. And this is the first example that we're going to work with transactions. PL Python can consume transactional data. And the TD is the magical transaction dict, okay, which holds the new row, which is going to be inserted, and a column, the review, which we are interested in. And it returns modify because it modifies the actual inserted data. There are several values that you can return, but please read the documentation for that. Okay. And this is the super complicated sentiment analysis I have ever seen in my entire life because I don't do sentiment analysis here. I take provide the review to my text blob, and I get the sentiment, and this is the best algorithm, best deterministic algorithm for sentiment analysis. If something is greater than 0, it is positive. If something is less than 0, it's negative. If something is 0, maybe it's neutral, maybe it's nothing. But yeah, it's sarcasm. I don't know whether your sentiment can be neutral. Everything works, but hey. And we can store that reaction and polarity in this reaction column. So what we have done here is the developer doesn't know what is going to be with that review, how you're going to compute that, but your maybe ML engineer, database engineer, whoever writes this function knows how to analyze sentiment, knows deeper than developer what to do with that data. Maybe it should be truncated, maybe it should send to another server to do something with that. But we are decoupling that part. And we are always sure that when this record is inserted in your database, it has an analyzed sentiment in it. Okay, but there are always downsides to great things here. This can take ages to compute. Of course, for text blob, it's very fast, it's instantiated. But if you're doing real ML or real sentiment analysis, it can take minutes, hours, maybe based on your text. Be very careful when you are blocking your transaction. This blocks the insert, and after triggers also blocks your transactions. Be very careful when you are doing scary things like this. This can be illegal. Your queries can time out, you can lose the data, and user will don't know why their review isn't stored in your database. Nice. And so I clearly remember this day. It was morning. No. Okay, I don't remember when I did this. But PostgreSQL is a fantastic tool for storing your data. It's atomic. It doesn't lose your data. You can store anything you want, binary data, files, text, whatsoever. And I decided to store a database in a database. Okay, and I decided to store my SQLite database inside my PostgreSQL database. It was a question, can I store SQLite database in my PostgreSQL? And it was a silly question, and I decided to answer it. Why? I don't know why I decided to answer that, but I created, I'm going to show you the anonymous code blocks. There is no single function which performs that, but I'm going to show you the flow, how can you store your database inside Postgres, and how can you retrieve it. Okay, let's try to store our small SQLite databases, which I admire a lot, inside another database, which I admire a lot as well. I'm creating this small table, which is going to store the SQLite databases in bytes. I tried in smileys, but it didn't work. And the primary key here, which I'm going to retrieve the database, and this first block, how to store the database inside the database. I split the code between slides, so we're going to just pass through some of them. I create an in-memory database. Of course, I can read the actual database from the disk. SQLite can do that. Python can do that. I create some very small table to ensure that my data is serialized and I can later retrieve it. I insert data into it, and we store it, finalize the process, and I prepare this query. If you want to execute a query from PL Python, first you have to prepare it. Everything good is prepared in oven. Okay, so we prepare this query, we insert this SQLite database into our SQLites, and this is the magic part where everything worked well. It appears that some guy thought that it's a great idea to provide a user interface, a programming interface, to serialize your SQLite. I don't know why, but there was already this serialized. You can always serialize your SQLite database in Python and maybe stream it to another server. Bake it up, or I don't know why. But serializing this gives me the bytes, actual bytes of SQLite database, and I'm storing this and closing the connection to the SQLite. This is fantastic. I'm storing database in database. I have tons of these. I store my users' specific databases in my big table. Maybe you can sync your mobile application's SQLite database to your server and then store it on PostgreSQL and then set up a backup for this PostgreSQL, which will back up all the SQLite databases. It's silly how you can do, how can you achieve such things. And of course, this is the storing part, and storing part is nothing without the retrieving part. And retrieval is the same thing. We are importing the SQLite and PL Python. We are creating an in-memory database. We can, of course, create a file here. We are selecting this SQLite from SQLite. We're deserializing it, and everything works correctly. You can then query the SQLite database using this connection and have your database here. And there is a question, can you store SQLite in SQLite? Okay, and then store it in Postgres. But I think we all know where recursion leads us, so let's just skip it, okay? I don't want to dive deeper inside it. I thought this was scary enough. Okay, maybe the day is off, we can just wrap it up and go to lunch. But actually, no. Okay, so I was preoccupied with whatever I can do more, and no one asked me why you are doing that. I have a great CTO. Yeah, I'll answer that question, but after the session, okay? And I decided to create one of the most reliable servers in the world. So PostgreSQL uses client-server architecture to serve your data. You connect to your PostgreSQL server using some client. It may be a remote client, of course, and you do queries, you return your data, everything is fine. But that escalated quickly. Okay, I decided to put my web server inside my database, and I decided to, I can serve my web application directly from my database. Okay, I can serve my HTML files, I can stream videos, maybe create another YouTube alternative directly from my database. And now I'm going to just fast forward through some slides to show you the amount of code that is required for doing this. And we're going to go slides one by one. Okay, so the setup is this. Okay, the procedure, which creates an HTTPD, the WHGI application, the server, how you call it, and the reaction. Okay, it was, oh my God, it worked, just worked. It was fantastic. And let's go through the procedure. What is a procedure? So nowadays, I think the most programming languages have functions. Okay, functions, defs, or something else. But in ancient times, there were programming languages that had both procedures and functions. And what is a procedure? It's a function which doesn't return anything. It doesn't have any return value. Function which returns nothing, void, null, nil, is a function because it returns something. The procedure doesn't return anything. And when you are running some HTTP server there, I don't think that you need something to be returned. Nice. This is the setup, okay? I'm importing the signal, and I won't tell you why. It was hard to come up with that, and it must be hard for you to digest that. So some small setup, typing, mapping, WHGI ref, which is the server PLPy, and the actual WHGI application. This application is written according to PEP 3333. It's actually the number of the PEP. And it gets the environment, the start response. It responds with 200 OK. It sets that content type is text plain. It returns hello from PostgreSQL. This is a function, just a function living inside this whole procedure. Every Python code that I'm going to show you for this is living inside this HTTPD wrapper function. So this is the application. This handle signal, I'll come back to it. And it's this make server which receives the port, this port, an integer, and serves your application on that port. This the function application is serving HTTP on your port. You can invoke that by calling HTTP D1818, specifying your port, and everything works. When you open your browser, it will display the this hello from PostgreSQL, the plain text response. Fantastic. I've even managed to write a reverse shell for PostgreSQL. I didn't have access to the PL Python shell, and I thought, what can we do with that? And I deployed the server, the shell, and it was instantly vulnerable application. The most vulnerable thing that I have deployed to a database, because when you called this procedure, it opened the shell, and you could write in it a command, SQL command, and retrieve the data. But you can do anything that you want with this application. This is the WHGI, the synchronous version of Python application, Python web application. You can write a synchronous application. You can write anything you want. Just imagine a web application that you can create, and you can deploy it to your Postgres. Fortunately, PostgreSQL function calls doesn't have a default timeout. So that means unless you stop this procedure manually or stop your database here, this will run indefinitely. This is the most reliable web server I have ever written myself. Okay? So no web application that I've written myself. The problem was I stuck upon when you want to cancel this query. Imagine you're running call HTTPD 1818 and you want to terminate it with Control C or some signal. It hangs. You cannot kill this. So you have to restart your database and start it again. But it's awful. That's why I introduced this signal handling. Because each time you terminate a PostgreSQL query, it actually sends a SIGINT to that running process, and it wants to terminate that process. So this is SIGINT, which handles the signal, which just exits my PL Python application. So I think the reaction was proportional to what I did there. There are a lot of things that you can do, and all those scripts, the better version of those scripts are open source. I'm going to share with you that repository. And there you can actually query a remote server, make an HTTP request, download the data, represent as a table, and join your physical table with the virtual one which you have created from that remote server. And that example is actually in the database. In the GitHub repository. The best part is that you can access the massive Python ecosystem, the best ecosystem in the world, the most adopted ecosystem in the world. I know that everyone wants to rewrite this in Rust, but no, okay? Just leave this PL Python alone, okay? It's running Python, it's fast enough, it's super fast, it's faster than anything. So data stays inside the database. It's very important when you want to do an analytics. You cannot share your data somewhere else. You don't want to extract your data. You can create those functions, your analytical workflows inside your database, maybe your replica or backup somewhere else. You can crunch those numbers without sharing anything. So rapid prototyping, you can reuse your Python knowledge, trigger support, context support, everything that you want is there. And we're going to skip the worst parts, okay? Because worst parts are not interesting or interesting. Okay, it's untrusted language because Python is so powerful that PostgreSQL just can't trust it. Okay, you can do everything with it. So you have performance overhead because SQL is slower than Python, pun intended. So you can always have some problems with your queries because if they are querying external resources, downloading huge data, blocking your transactions, you can have problems with your queries. So please be very careful when you define some Python code inside your SQL, because your Python code may be compiled with WebAssembly and run a small browser in it, which does some automation. Be very careful. Deployment and portability challenges. Who wrote that? Who wrote that? Okay. Just wrapping things up, this is the repository containing everything I have told you and much more. There are very interesting scripts inside it. I hope you will enjoy them. Please, for now, contributions are closed because I'm thinking about the contribution guideline, which now has only don't in it. I'm going to open it. There are discussions. Discussions are open. If you want to discuss anything with me, please contact me or not. There are some resources here, the blog post, the official documentation here. And of course, you can PL Python your questions here. Thank you.
What about comparing with native PostgreSQL types and Python types? I think it's mind border to use this in the everyday routine. It's we cannot, for example, return simply JSON-B because we need serialization and deserialization.
It's actually a good question because the mapping between the SQL data types and Python data types are very limited because the SQL data types are limited. So you can either, for example, serialize in bytes, store in bytes, and then provide it to your application whatsoever it wants to do. For instance, I have a script which generates matplotlib charts for my data, and it cannot return those charts. It stores in bytes, for example, and then when web application requests not the data, but computed charts, it can request those images, those PNGs, and provide to the user. There is zero overhead on the computation part because the charts are there. But of course, there is limitation between those data types.
And sorry, maybe one question, okay? And what about if you have multiple PostgreSQL servers, and how to deploy synchronously on the different servers new version of your function?
I think it's about the standard migrations, because when you want to create a new table inside your cluster, you deploy to some job which provides those queries. This, when you want to create a function, it's just a simple SQL query. Just please let me find the simplest example here. Okay, this function. This is an SQL, valid SQL expression. You want to deploy it, you put it in your migration jobs, whether to deploy it to the cluster, it's there.
I mean, when we execute create or replace function on the different servers, we cannot guarantee consistency between logic on the different servers.
Yeah, but you cannot guarantee the simple SQL create table as well, or create index as well. I think it's mostly delegated to the migration systems, where your migration succeeded or not.
This is a perfect thing to follow up.
Yeah.
So there's another question.
A lot of Python functions needs a virtual environment for installing the dependencies. How PL/Python or in the Postgres we can manage the virtual environments and installs or dependency and run it on those servers?
Nice, it's a very good question. So actually, PostgreSQL uses the Python on the host. So if you, just skipping a bit the VAMF part, if you have installed the Python on the host and the libraries on the host, PL/Python can use them. You can also activate if you want to use a virtual environment or something isolated, you can activate your virtual environment from within because PL/Python has a lot of configurations, okay? Or maybe you can chroot your Python somewhere, or maybe use Docker containers and run your PostgreSQL inside the container and Python inside the container and install all your dependencies inside it with an isolated environment. So yes, you have this support of everything you want, but make sure that the PostgreSQL executes the host sitting Python. It doesn't bring anything with it.
From Python 3.12, we need to define an environment to run our Python codes, and it's always run with a venv. So, is there a way that we can give a venv address to?
Honestly, I got your question. Honestly, I didn't try to use the venv because my setup is inside the Docker container. The GitHub repository, which I mentioned, also provides the Docker setup. So let's say it's the host Python with host pip. It's a very good question. I'll look into it. But I have seen some configuration options when you provide some venv. I don't know whether it is a fixed position or the path within it. Just I haven't dug into it.
Thank you.
We still have time. Why? One more question.
It's actually a good question because I like, as I've told you, I like to break stuff and I want to push boundaries. I want to know my technology. I want to know what I can do with Python, I can do with PostgreSQL, whether I can automate something or just break the barriers. So just basic engineering stuff, nothing fancy.
Well, I have a question. I was thinking about like embedding SQLite into PostgreSQL, what the use cases might be. One, for instance, would be just giving AI knowledge, compressed knowledge, basically, one database, and you have all the SQLite that AI can access to all different knowledges in one place. Have you thought about trying any use case with that?
It's actually a good use case, but as I'm not doing too much the ML AI thing, I haven't done it. But I use this setup for backup because I know that you can just copy your SQLite file inside a backup directory or retrieve some. But if you have some nice small backup solution and you want to backup your main database and you have many small, the keyword is small. Yeah, small SQLites, you can just store them as a. And also, PostgreSQL compresses the SQLite, those byte AIs with its toast compression. So everything works great.
There's one more question. Yeah, we still have time.
Going to leave this.
Maybe I missed that part, but how does SQLite sit in the database? What is the data type? What is the...
Yeah. The schema here, which stores the SQLite, I'm going to, here. This SQLite column is type of byte data. Is the row bytes representation of PostgreSQL. So you have a column which can store row bytes. Okay. And I can serialize my SQL data as a row byte because the SQLite is just basically a file sitting in it. This example was a bit funny because I didn't read the SQLite as a file and serialize it as bytes and sending it to the database. I used this connection serialize to get those row bytes from the SQLite, so the representation of the SQLite, and just inserting those row bytes inside this SQLite table as SQL, because everything, you can access everything as just row byte.
Any limitation about that? I mean, about the performance or?
It always depends on the size of the SQLite. If you're reading, for example, 1 megabyte SQLite database, it will be very fast. If you're reading 500 gigabytes of SQLite database, it will be not so fast. But of course, you can store it because PostgreSQL doesn't have any. It has a limitation on the number of columns, but it can store huge data. It is a worst practice that you can do because your database cluster will be clogged. So don't store terabytes of data in one single column. But of course, it's possible. If you're just talking about possibilities, there are large objects in PostgreSQL where you can define that this is large object and I'm going to put files in it. This is just a toy example which can store binary data.